Prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So we start with writing the first even number and assume that it's 2n, because all even numbers are multiples of 2, and so 2n is the first even number. 2 is the first even number. 2 times when n equals 1, 2. So the next even number would be 2n plus 2, not 2n plus 1, because if n equals 1, then 2n plus 1 would give you 3. So it's 2n plus 2 always. So the question is telling us that the sum of the squares of any two, so we have to square them and add them. So what I did was, so I then took 2 outside, and then it becomes 2 times n plus 1. And then I named them just a and b. You don't have to, but I did it because I thought it was easier to explain. So I call this a, and I call this b. And the next step is to sum the squares of a and b. And then it's 2n whole square and plus 2 within brackets n plus 1 whole square. And this will give you 4n square plus 4 times n plus 1 whole square. And then you expand n plus 1, so it becomes 4 times n square plus 2n plus 1, and this remains 4n square. Multiply the things within the bracket by 4 and remove the bracket altogether, so you're left with 4n square plus 4n square plus 8n plus 4. And then adding up 4n square plus 4n square, you get 8n square plus 8n. It's already there, plus 4. And take 4. Now this is a multiple of 4 clearly. So you see, if you take 4 outside the bracket, you get 4 times 2n square plus 2n plus 1. And this is a multiple of 4. So we have proved that the sum of the squares of any two consecutive even numbers is always a multiple of 4.